So let's begin this section with the following problem, which is actually a review of the previous lesson, but there is a reason behind this review, as you will see. You invest 500 now at an annual simple interest rate of 8%. What is the effective rate of interest in the fifth year of investment? So the simple interest formula we know is A of t is equal to principal times 1 plus IT. And P is 500 in this case. I is 8%, so 0.08. And we want the effective rate in the fifth year. So our notation for that was I subscript 5, lowercase I, as we studied in the previous lesson. So I of 5 is A of 5 minus A of 4 over A of 4. Remember, I of n was A of n minus A of n minus 1 divided by A of n minus 1. And so this would be, when you substitute 5 in this, so A of 5 comes out to be 500 times 1 plus 0.08 times 5. In fact, let's just write it as 0.08 times 5. And this would be 1 plus 0.08 times 4. And this whole simplifies to 6.06%. Now, the point to be noted here is that the annual rate was 8%, but the effective rate during the fifth year was 6%. Now, this will always happen for simple interest, that whatever annual rate you are given, your effective rate for any year will actually be lower. And in fact, it keeps getting lower and lower the further out you go into the year. So the effective rate of sixth year would be even lower than 6.06%. However, in case of compound interest, if you were given that this is a compound interest with rate of 8% and everything else was the same in this problem, then the effective rate for the fifth year would come out to be 8%. It would be exactly the annual rate that was given. And so that's a very important difference. In fact, compound interest is the only kind of interest which enjoys this property, that whatever annual rate is given, that's also the effective rate for any year. Now, the key takeaway is that anytime you are given that the effective rate during, so if you're told in a problem that the annual effective rate is constant, that means we are talking about compound interest. So they may not explicitly tell you that the interest you are dealing with is compound interest, but if they tell you that the annual effective rate is constant, then that's compound interest, because compound interest is the only kind of interest for which the annual effective rate is constant. Okay, so now we are finally ready to do our first SOA sample question in this course. It will not be sample question number 1 because we haven't yet developed the tools for it, but we have the tools for sample question number 27. So let's see. Robbie and Bruce each open a new bank account at time 0. Bruce deposits 100 into his bank account. Robbie deposits 50 into his. Each account earns the same annual effective interest rate. Same annual effective interest rate. So we are told two things at the same time here. One is that the annual effective interest rate is the same for both Bruce and Robbie. And the other thing we are told is that the annual effective rate, interest rate, is a constant. And that, according to the remark that we just made a while ago, that points out towards compound interest. So we are indirectly told that both Robbie and Bruce are dealing with compound interest. The amount of interest earned in Bruce's account during 11th year is X. The amount of interest earned in Robbie's account during 17th year is also X. Calculate X. So the formula for Bruce will be 100 times, so Bruce's principal is 100. So we know generic formula for compound interest is equal to P times 1 plus I to the T. So in this case, the principal is 100. So it would be 100 times 1 plus I to the T. And we are talking about Bruce's interest in the 11th year, and that's equal to X. So we know from an early lesson that the interest in the 11th year will be the amount at the end of 11th year minus the amount at the end of 10th year. And that is equal to 100, 1 plus I power 11. That's A of 11, and A of 10 is 100, 1 plus I to the 10. And we are told that this is equal to X. So this can be also simplified by factoring out 100 and the lower power of 1 plus I, which is 10. So when you factor out 100 times 1 plus I to the 10, you are left with a single power of 1 plus I in this first expression and a minus 1 in the second expression, because all of this was factored out. And the 1 and the minus 1 cancel out, and this simplifies to 100I times 1 plus I to the 10. So for Robbie, the principal was 50, so A of t will be 50 times 1 plus I to the t. And we are told that Robbie's interest in the 17th year is X. So in the 17th year, his interest would be A of 17 minus A of 16. So A of 17 is 50 times 1 plus I to the 17, and A of 16 is 50 times 1 plus I to the 16. So again, we can factor out a 50 times 1 plus I to the 16. So we're left with 1 plus I from the first expression and negative 1 from the second. So we get 50I, 1 plus I to the 16, and we're told that that's also equal to X. So this is also X, and this is also X. So you set this expression equal to this one. So 100I, 1 plus I to the 10 equals 50I, 1 plus I to the 16. And now you divide both sides by 50I times 1 plus I to the 10. Because both 100 and 50 are divisible by 50. That's why we have the 50. And then we have the I because both sides have an I. And then we have the 1 plus I to the 10 because that's the lower power on the two sides for the 1 plus I. So on the left side, we will just get a 2 because the I and 1 plus I to the 10 will be completely canceled out, and 100 divided by 50 will be 2. And on the right side, the 50I will be completely canceled out. And when you divide the 1 plus I to the 16 by 1 plus I to the 10, you get 1 plus I to the 6. Now you take power 1/6 on both sides. So 2 power 1/6 is 1 plus I, and that gives you I equals 0.1225. The question was to find X, and X can be found from either Bruce's equation or Robbie's equation. I'm using Robbie's equation. X equals 50I, 1 plus I to the 16. And when I substitute the 0.1225 for the I get 38.91. That was choice E.